Alrighty, and we may have that mystery voice off camera again, but Mr. Sustin is rounding the corner of the table here.
Right.
So now we're going to look at another example of oxidation rules. And what about one of the magic 7? What about those elements? Something like iodine.
Iodine, I2.
I too would like to know
I2,
what
yes.
the oxidation number of iodine, the molecule is.
Right. Is this an element that is combined with a different element?
No.
So that makes this a diatomic element. It's an element. It's a free element.
It's a free element.
So its
Free
oxidation
elements don't
number
cost
is
anything.
0.
Oxidation number is 0.
0.
But what about, well, what about another element like, I don't know, strontium?
Yeah, what about it? It's
Well,
a free element.
Oh, it's a free element too.
Yes,
So
but
its
it's
oxidation number,
is 0.
still 0.
Currently. Oops,
Sorry?
sorry.
And you're gonna
Currently,
say-
it's 0. You can have different forms of elements, like I thought you were going to pick this one, because we'd actually done this before.
Right, oh yeah.
Yes, this is a form of sulfur. Sulfur bonds to 7 other sulfurs to make an 8 sulfur molecule.
Mm-hmm.
Even though it's 8 sulfur atoms bonded together, it is still a free element.
Free element. Okay, and they all have an oxidation number of 0. I think that was like rule number 1.
Yes, 4. Sorry.
Moving on, number 9. How to write the specific oxidation numbers for each element in a given compound. So here is, again, is where you're going to apply those oxidation number rules that you know and love. And how about an acid? Let's take a look at some of the acids. This acid is...
It's a bad managing it. That's a pretty strong acid. Now it is.
Yes.
Now
It's
it is.
a very strong acid. I agree wholeheartedly.
Now it is.
And it's got 3 different elements in it.
Yes.
And we can apply or identify the oxidation number of each element using the rules. And we
Use the rules.
know that there are special rules for hydrogen and oxygen, so it's very convenient that we have hydrogen and oxygen in here.
Yes.
And for it,
Rule number 2 says that 99.9% of the time, hydrogen is a +1 oxidation number. And rule number 3 says 99% of the time, oxygen is a -2 oxidation number. If you take into account the number of hydrogens and the number of oxygens, you end up with a net charge of, what's the net charge of a neutral compound?
a neutral compound, the net charge is going to be 0.
Okay, so let's change that question mark to
Comes
0.
down to 0, so we know that.
And let's see, the rule 6 says the sum of the oxidation numbers of the atoms in a compound have to equal 0. I'm not sure what sulfur is.
Right.
If I look on the periodic table, I can kind of make a guess at what sulfur could be, but
Right. And we can guess because in a lot of cases, all you have to do is count over and figure out how many how many valence electrons the element has, and that's what it tends to be most often. Is that what happened here? Well, if we've got 2 plus 1 things and 4 minus 2 things, we need to know 2 plus what number is -8 is going to give us 0. And we all can do math. Unfortunately, some of my kids say 10, but we can do math, and we know that,
if we do a little combining like terms,
yep,
and then solve for x, we have sulfur must have been, in this instance, it must have had a +6 oxidation number.
right. Now sometimes I know what throws my students is that they see sulfur and they know that sulfur is a non-metal and they know it's 2 away from the octet, and they always want to put a -2 charge there. But in this compound it's different because sulfur is now trapped in the middle. And when we were little, And before you had DVD players in the back of the minivan, and you had to ride on family vacations in the back seat of the Buick with your snotty little brothers, of which I have two, I always had to sit in the middle
I was a snotty brother.
to keep these snotty brothers from beating each other up from Ohio to Michigan. So I was the peacekeeper in between. Well, I had to adapt and make sure that both sides played nicely with each other. That's what sulfur's doing here. Sulfur's oxidation state can change up a little bit depending on how many oxygens are attached in this compound, or in a compound similar to this, made of these elements. So instead of being the negative oxidation number that you might expect if it was just a binary compound, two kinds of atoms, here sulfur is going to be positive to make up the difference between the positive end and the negative end. All right?
There you have it. You want to do another one?
Oh, should we do another example? Yeah, let's do another example.
Do a nitrogen.
A nitrogen compound?
Yeah,
Okay.
do a nitrogen.
All righty.
Go for it.
I will do that. How about another kind of acid, another strong acid, and that would be nitric acid.
Yes.
Okay.
Is nitric acid a neutral compound?
It is a neutral compound.
Okay, that becomes important.
So we know that everything's going to balance out to 0 here. Well, conveniently, we still have hydrogen at the beginning and oxygen at the end, and we know hydrogen and oxygen, when we see those, we can start by applying a +1 oxidation state to hydrogen and a -2 to oxygen. This is kind of nice because there's only one hydrogen, so we've got a positive one thing there, something we need to figure out in the middle, and then we have 3 elements that have a -2 charge, so that's going to be a -6. Whoops. So 1 plus what number? -6 equals 0. Clearly, that has to be a 5.
Yes.
Okay?
For some of my students, it's not clear.
Oh, so we do the algebra.
And
Do
so,
the algebra over Mr. Sustis.
yeah, let them go ahead and do that algebra, encourage them to solve that problem all the way through. And, you know, you've been doing this math for a long, long time.
Right.
Let this skill that you're good at
Right.
help make this easier.
And you know how to add and subtract on a number line. Okay?
Yeah.
Use what you learned back in elementary school.
You betcha.
All right, moving on.
Where are we?
I don't know, where are we?
We're on number...
10.
No, yeah, 10. How to identify an element that is reduced in a specific reaction. And we decided we were going to do a
Okay.
couple examples.
Yep. We actually planned ahead of time this
Yeah.
time. Usually we're just up here winging it. But we actually thought about what we wanted to tell you.
As though you hadn't noticed.
Oh, no. They had me.
We've got fluorine reacts with, did we decide sodium iodide?
Chloride.
Chloride.
Yes, NaCl.
NaCl. To form sodium fluoride and
Chlorine.
fluorine.
Okay. But what Mr. Sustin did here was wrote fluorine the element diatomic and chlorine the element diatomic because we know they're part of the magic 7. Okay, and in this question, we want to know which element is oxidized
oxidized.
or reduced. So
Right.
let's do both. Well, first we need to figure out what the oxidation numbers are. Why don't you do that side and I'll do this side,
Okay.
and then we'll meet in the middle and see if we think
Okay.
we're right. So I'm going to do
Rule
this.
4,
Yeah,
Rule 1,
yeah.
Rule 1. Okay.
Okay. And we came up with something pretty similar. The diatomic fluorine, element by itself, oxidation number of 0, just like the diatomic chlorine, element by itself, oxidation number of 0. And then we know our sodium, because it's in column 1 with 1 valence electron. And we kind of picked this one on purpose because we knew we had halogens here that would be -1.
Yes.
So now we know the oxidation states, and we need to figure out which substance was oxidized and which substance was reduced. So we
Right.
got to look for some change.
Which one changed? Well, I can clearly see that sodium didn't change.
Right. So we could almost erase that.
Yeah, but we won't. And then, so fluorine on my side went from a 0 oxidation state to a -1 oxidation state. Now, how did that happen to poor old fluorine? If it went from 0 and became negative, it must have gained
Right.
an electron.
So we could write that in, and,
Right.
because I didn't plan it, oops, not two, what am I doing? We're gonna put one electron on that side, it really doesn't matter if you write it before or after fluorine.
I was telling my kids that we don't even really need to worry about this, because
Yeah, we don't need to worry about the fact there's two of them yet.
we're concentrating on what happened to a fluorine atom. Because,
Right.
yes, there's two fluorine atoms here, but each of them has a 0
Right,
oxidation number.
and we're not balancing this equation yet, so we're not
Yeah.
putting on that level of understanding.
I have to say, my
They don't
heart,
get it, though.
my heart was warmed when my students looked stressed that the equation was not balanced.
So they know stuff.
They already
from their
know
ninth
what's
grade
coming 2
class.
chapters down the road.
That's awesome.
Yes.
Okay, so this was what kind of reaction again?
We decided this was gaining electrons,
Right.
and Leo says grr. So this is reduction.
That is reduction.
This is reduction.
All right, and we noticed that sodium was +1 on this side and +1 on that side, so we don't have to worry about that. And now chlorine went from a -1 oxidation state to a 0 oxidation state. -1 to 0 is becoming more positive, okay?
Mhm.
And to do that, it must have shed its negativity, which means it shed valence electrons,
Mhm.
right? So we would have and our electron on this side, and we're showing that electron being lost. So this is an oxidation equation.